A2.
Hit. B8.
Miss. A3.
Ah, you sunk my battleship.
Yes.
If you've ever played Battleship, or if you've ever found a city or a town on a map, or used a map to locate something even in the mall, you've used the rectangular coordinate system in some way, shape, or form. Okay, so here is the kind of rectangular coordinate system, or the Cartesian plane, that we'll be using in math class. It's formed by the intersection of two lines, a horizontal line, which is also known as the x-axis, and a vertical line, also known as the y-axis. So the x-axis is really the number line, where the x and y-axis meet. That's our origin. Okay, all the numbers to the right of the origin are positive along the x-axis. They're negative to the left along the x-axis. And the numbers on the y-axis or above the y-axis, those are positive, and the ones below the x-axis are negative. Okay, so just like our number line. All right, now the Cartesian plane is split into 4 quadrants. The upper right is the first quadrant, the upper left the second, the lower left the third, and the lower right is your 4th quadrant. So our quadrants: 1, going counterclockwise, starting at the right, upper right, 1, 2, 3, and 4. So every location on the Cartesian plane is made up of an x-coordinate and a y-coordinate. That makes up our ordered pair on the Cartesian plane. Okay, so we always do the x first. It's alphabetical order. So the origin, of course, is at 0, 0. Okay, so we know our origin is right there, and that ordered pair, might be tough to see, is 0, 0. And then we can find other locations on the Cartesian plane. So if we wanted to go maybe to the right, or let's go to the left. Let's go to the left 5 units and up 4 units. That location would be right there. So that ordered pair, negative 5 on the x and 4 up. We could find another location. We might go to the right. We could go 8 units and down, let's go down 6 units. So that location is at 8, but negative 6 on the y. So 8, negative 6, x, y. One thing that's somewhat implied in here may seem pretty obvious, but all the ordered pairs in the first quadrant are made up of positive x's, because we're to the right of the y-axis and above the x-axis. So all our x's are positive and all our y's are positive. It may seem obvious, but will be helpful to you in your math career to quickly grasp that. So in the second quadrant, our ordered pairs there, our x's are going to be negative, but our y's will be positive. And in the third quadrant, both the x's and y's are negative, so negative, negative in the third quadrant. And the fourth quadrant, those ordered pairs, x's again are positive, but y's will be negative. So along the Cartesian plane, we will be graphing many things, but one thing we'll be graphing is lines. And lines are equations for lines. One format is standard form of an equation in 2 variables. In this case, x and y are variables, and in fact, a, b, and c are going to be numbers in standard form. They're integers, and we'll talk more about standard form later on. Okay, so here's an example of an equation in 2 variables. 3x minus y equals 12. If we graph this, this would be a line. Any ordered pair, any x and y on the line, will satisfy this particular equation or make that true. So you're going to get questions like this. Determine whether the ordered pairs 0, 12 and 1, negative 9 are solutions for the equation. Okay, So 0 is our x and 12 is our y. So we can just substitute those two values into our equation for x and for y. So our x was 0, so that'd be 3 times 0 minus 12. Well, does that equal 12? That's supposed to be a question mark there. So 3 times 0 is 0, so we get negative 12 equals 12. And of course, that ordered pair does not work. It's not a solution to the equation. Let's try 1, negative 9. Well, that's 3. Our x is 1. Our y is negative 9, so minus a minus 9. Well, does that equal 12? Well, 3 plus 9, does that equal 12? Sure enough, 12 equals 12. So 1, negative 9 is a solution. So we'll find that particular point on that line. In fact, there are an infinite number of ordered pairs, x's and y's, that satisfy that. They can be fractions, they can be negative numbers. There's all sorts of solutions to that equation. Likewise, there are an infinite number of solutions or ordered pairs that are not solutions to the equation. So you've got to watch out for that. So you've probably done this in grade school as well. Given y equals 1/3 x minus 1, complete the table of values. So we're really asking you, okay, if we give you an x of negative 3, what's y going to be? So this one's set up for you. It's not in standard form, but it still is a linear equation where we're given x is negative 3. So y equals 1/3. We substitute negative 3 in for x, and we solve for y. So that's y equals negative 1 minus 1, and we get y equals negative 2. So when x is negative 3, y is negative 2, so that's going to be the ordered pair negative 3, negative 2. And again, we're asking to substitute 0 in for x to solve for y. So y equals 1/3 0 minus 1. We're going to be substituting 0 in for x quite often this year. So get used to that. So y equals negative 1. So now we know when x is 0, y is negative 1. This one's a little different now. We're not substituting for x, but we're substituting for y. We're given the y value as 0. So that one, 0 equals 1/3 x, not negative 1/3 x, 1/3 x minus 1. So we add 1 to both sides. 1 equals 1/3 x. We multiply both sides by 3 to isolate x, to get x all by itself. So 3 over 1. So 3 equals x. So now we know in order to get a y of 0, x must be 3. So that is going to be our ordered pair 3, 0. So that's the ordered pair 3, 0. And these are kind of neat. These are neat answers. When x is 0, that's actually when our graph crosses the y-axis. That's called the y-intercept. And when y is 0, that is when our line crosses the x-axis. So that's the x-intercept. So frequently we're going to graph the y-intercept, set x equal to 0, solve for y. And we're going to try and find the x-intercept, where we set y equal to 0 and solve for x. You will also be graphing paired data. Okay? In this data set, we're given a year and sales. So we know in 2006, this company had $58 million in sales. In 2007, 61 million, and so forth. You're going to be asked to create a scatter plot and then determine any kind of trend in the data. Well, I want to talk a little bit about dependent versus independent variables, first of all. Okay? Dependent versus independent. What we're going to see in math class is we are going to see that y often depends on x. Okay? So whatever, if we have some data here we've got sales and year. Well, sales depends on the year, okay? You know, as the year changes, our sales change, okay? If our sales change, we can't force a change in the year, okay? So we know here that sales depends on year. So sales is our dependent variable. This depends on the year, which are our independent variable. Okay, so this is our dependent variable, and this is our independent. So we know that our y in our ordered pair is sales, and x is the year. So we're going to take this data, and we're going to create an ordered pair, xy, which of course then will be some year, some sales. Okay, so we've got this set up almost like a table of values. That's our x and that's our y in our ordered pairs. So we have this series of ordered pairs, 2006, 58, 2007, 61. So now we want to graph this. And now we know, since we know our dependent and independent variable, we know what goes on both the x and the y-axis. So our x-axis is going to be year, and our y-axis is going to be sales in millions. Okay, so we're going to have to do a little cut in our graph here and label our x and y-axis, and we're going to start with our sales. I think we'll start right at 58 million, and let's go by twos: 58, 60, 62, 64, 66 million. And the years: 2006, 07, 08, 09, and 2010. So now we can graph. We've got our x and our y. So 2006 corresponds to 58, so we'll graph that particular ordered pair. And 2007 was 61, so we'll graph that. 2008 was 63, so we'll sketch that. 2009 was also 63 million. Sales were flat during the recession. And 2010, we had a jump up to 200, or to 66 million. So we've got our ordered pairs here that we've plotted on the Cartesian, or the first quadrant of the Cartesian plane. And it looks like our data has a particular trend that looks something like that. So a very nice upward trend for this particular company over those years in their sales. You will also have word problems. So here's a word problem in which I purchased a new iBrick for $1,550. The iBrick is estimated to lose $275 in value each year. Calculate the iBrick's value for each of its first 5 years. Use the equation y equals negative 275x plus 1,550. So here's my equation. I've set up a table, kind of a table of values with my equation in the middle. So I've got some x's. X's are going to be time again. My independent variable is the year, and my value is dependent variable. So my value depends on the year. So in year 0, when I purchase it new, I put 0 in for x into my equation or my mathematical model, and I get a y, or a value of $1,550, which of course is the ordered pair 01550. I'm going to skip 1. I'm going to go to 2. I'm not going to do every single one of these because I think you get the hang of it. Negative 275 times 2 in year 2, what's going to be my value? Well, 275 times 2 is 550. So my value, or my y, is going to be $1,000. So after 2 years, my bricks dropped in value to $1,000. Let's skip to 4 years. Again, I think you'll get the hang of it, and you can do the other 2 years that I don't complete. So 275 times 4 is 1100. So that's a negative 1100 plus 1550, which gives my iBrick a value of $450. So after 4 years, my value is down to $450. So not too long before my iBrick is pretty worthless. But there's an example of how we can use a linear equation to determine the value or apply it in a more realistic sense. So that's a good start to the rectangular coordinate system. A lot of information here. Going all the way back to the beginning, we've done some word problems. We've applied linear equations. We've done a scatter plot. Okay, we've used a table of values, a couple different ways, but finding the x or a y when we're given one or the other. We found the solution, or one of the solutions of a linear equation. We've determined if an ordered pair is a solution, and we've introduced the rectangular coordinate system or the Cartesian plane. So we will see you in class.